Welcome to my stream, where knowledge reigns supreme. Calm and collected, I'm about to go live, you know what I mean. Got high expectations, gonna teach you something new. Learning and hacking, explore.
Connected to channel Fix at 42.
So much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unroll the secrets. All unlock the code. No limits, no boundaries. All knowledge will explode. Welcome to my stream, where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow. In this stream of knowledge, together we'll grow.
Fixerbot says. T-4 minutes.
Welcome to my stream, where knowledge reigns supreme. Calm and collected, I'm about to go live, you know what I mean. Got high expectations, gonna teach you something new. Learning and hacking, exploring, there's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unroll the secrets. All unlock the code. No limits, no boundaries. All knowledge will explode. Welcome to my stream, where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow. In the stream of knowledge, together we'll grow.
Why? What is this site? Come
Welcome to my stream, where knowledge reigns supreme. Calm and collected, I'm about to go live, you know what I mean.
Stream about to start. 1 minute left.
Expectations, gonna teach you something new. Learning and hacking, exploring, there's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unroll the secrets. All unlock the code. No limits, no boundaries. All knowledge
So I just managed to log in there. Yeah, so we were doing the Overflow one. So why is it not in like the list? Because this is favorites, okay? Modules. So well, so on TryHackMe, you just have a dashboard with your what you're on actually doing, not favorite modules. Why would this? I don't think I ever favorited this. I think it's automatic. Yeah, so here we have in progress modules. Shouldn't this be more? So this is finished. Okay. So did I log into the account I thought was deleted or gone? And I don't think so, because I think it had more than the introduction. And this one is not done either. So that's probably why it was like a favorite, because it wasn't finished, you know? Oh well. Let's click again this login there. We'll just hop to the page, right? I'll need to log out. So their new login system is more than annoying. So let's try this email address that was also here. I guess I'll do remember me. It does not match anything because it was deleted. So, alright, so maybe I should just click this one. Continue with HTTP account. And that's where I log in. So I don't think this is the correct one. I think I'm using this one. We'll see. Let's actually do this one. I didn't click remember me now. And that's probably the right one then. Yeah, binary. Yeah, we have a ad block. Okay. Technically support chat won't load. Okay. Yeah, so I've had problems. What was it? Some site I had to turn off uBlock and privacy badger that I didn't believe I would have to. But anyway, we just clicked a few of these to test stuff, and I think that one of them was expensive in their blocks, or what they're called, but so I thought it would say like you can't do this, but apparently the like bits of it you don't really pay for it until you click the separate parts. Whatever. Let's just continue. So we're at the very end of this, and I didn't have time to test again, because in all of this room they're doing something very odd, and the very odd thing is to make an exploit connecting by to the machine's own IP to localhost. And I was like, seriously, this is so odd. Let's just do my machine. And that didn't work. So I'm thinking that we'll just have to do as they say we should do, which is annoying. But we'll just have to spawn the system and finish this, because I want to get started with the Windows one. That's the next. The same thing, stack-based buffer overflows on Linux, but on Windows, right? x86. So, targets over spawning. I had helped my mom a bit to get service on her car, so I've been messing about with that for over an hour now. So I would have started streaming earlier than usual today if stuff didn't happen, like my mom getting in a very apparently scary alarm on her car saying she has to go to service. So though it's not very explicit, the message, so it should probably say you should go to service, not a countdown, counting down the days until it was 1 year in service, I guess. But it says like 10 days left to go. No details. It's not that odd that she got worried, really. It's kind of... Oh, right, my camera didn't work, so I had to restart my computer. That's probably because I was messing with the Snap camera yesterday and got it working. So, but I didn't want to use the resources to actually run it all the time, so I had everything started, then I had to restart, so now there. So we have TTS working, we have stream to YouTube and Twitch working. Callie has started. Now I can even switch screens. So there. So I have to wake my mom up at 7 tomorrow, but she wanted to be woken up at 5:30 to be able to leave home at 8:15. So I think she will manage with 7. I hope so, because I don't think I will be able to get up at 5:30. Let's see. So, right. VPN. Oh, the Academy apparently has a separate VPN. I don't know why they have 2. I don't think they'll run out of IP addresses, will they? Maybe they will. Sounds very... I guess it's good to have a lot, right? But still... It's a bit of a mess to have to have 2. Oh gosh, caps? How did that happen? It's not like it's hard to type 2 letters, so I guess. So let's go here and let's check. We have an IP over here. So if I click this, will it copy it? Yes. So let's Zage, and it's like almost the same address, whatever. It's not the same though. I think we got once we got the same address. Oh, and the password is htb _ at academy student. I'm copying this. Oh, that's me pressing Control Shift. Oh gosh. What I did was to actually copy again on Kali instead of pasting. There now. So here we have the leave message. We'll have to... I don't think we have to redo anything because I think it's very the same memory addresses and everything. So the purpose is really to read this message text. I think I was kind of like going to test the Try Hack Me Rooms exploit, but let's actually do both. But I feel like these are a bit messy. I mean, if this doesn't work to connect, let's look at the notes so you know what I'm talking about. So I'll have to open the notes again too. So if we go to the very bottom here, we should have like what we're currently doing, because I added it from yeah. So this is the current full example we're testing here. So we noticed this So I just have to disconnect the phone and connect it again. Okay. Come on. Oh, well, that was a bit funny. By mistake, I clicked the button for pause when I was just removing the phone from the stand. That's annoying. I'll have to be more careful when I do that. Anyway, let's go back to this. So this executable here, leave message, has a vulnerability. We found this buffer overflow. We tested with 2,500 characters, probably, since we used that here. And so it was kind of a large buffer. We don't have the code for this one, so we don't know exactly what's inside it. Though we did disassemble it. I feel like that's a bit of cheating, right? But it was a bit too much to read anyway. I mean, not worth it. So anyway, then we did run it with this, and we get this place in memory where it actually tries to return to, right? So then we got the exact position of this. And this is where the return address, or the address we want to redirect execution to, will be put later. But then we found bad characters. That's too much to paste into the notes, so I just skipped that. And then we have, so it's on last stream if you're curious, or maybe someone before even. So recently I haven't had time to stream for a long time. I've kind of felt it's good to do some exercising to get your body in shape. So I've been doing that. Here, this is the one where I changed it. So I put my IP here. Let's see if we have the same IP today. Yeah. Instead of 137.001, that was the suggested one. So I guess we will do the suggested numbers here instead of this time. And yeah, C format of the output, architecture x86, platform Linux, and the bad cars we found there. We could like put this here, making this a more complete example with actually finding bad cars. So these are just temporary because I was closing my VM down. I really would have wanted to finish this during the weekend at least, but I haven't really had time, not even yesterday. So many things to do. Found 11, she got an eye, and this is not what we'll use now then because of the IP. I think I have the other one still here. So their default one, no, I replaced it. So in my example here I had their one. So if this one works as the other one didn't, it is definitely something like limited on the box then, right? That you can't access ours. Let's not go ahead of myself. I was going to paste more stuff here, I didn't. Anyway, it connects when it's run. Only we can't do anything, right? At least I tried lspvd. Didn't get any replies from this at all. Maybe it would have worked to do ID. I didn't try ID. Anyway, we'll have to run it again. Yeah, here it is. So So this is of course supposed to be at the very end, since that's what we got there. So we'll have to run MSF Venom again. With the default information, we can check in the room instead of having to actually manually make a line. I'm more like after what they want us to do, right? So determine length, bad character generating shellcode. Here we will have the method venom command that they used with 127, the local host. I was like, why? No, I don't want to do this. Also, they do an out file and then they echo the out file. I'm like, why? So I did the Control Shift again. So Control C. Right, so yeah, they're catting it. They're putting it in a file and then they're catting it and copying it from here. So why not make an out file? I'm just like slightly annoyed. I shouldn't complain about stuff, I know. So it's great that this exists and that it's free, because it's free. So let's actually do a new try here. So this will of course not be in our main buffer overflow notes later, but new try doing it locally instead of trying to connect to my machine. And alright, it's already there. Actually, we can try the actual one I sent here first. So I was messing about with things. Starting program. But here is the run command. There. So if we were to run this, and it was the usual 443, not this any other port. Let's open a new tab and listen, right? And just giving this a second chance. So let's GDB, let's do the queue so we don't get the licensing information. We still have the glitches in connection there. Leave. I did click tab, nothing. Okay. Yeah, I think the GDB ones we have to type. Maybe /tab would work. So it's done. Now we're going to run it with this command. And there. And let's see if it's connected. It did. So it's not that it's not working, you know. It's just that it's not replying. So I think we'll have to do another SSH. This is what we did in the example, right? So I followed along with their example first. So we'll have to SSH to the same thing again, and I don't remember the IP, so let's just copy this. We could clear this so it's a bit prettier, right? So yeah, right, I still have to go there because I don't remember their password. So password here, there. Just Control C this time. So now we have one here and one here, and we will use their port too, just to be safe here. Shouldn't think yourself, you just should copy whatever they did, no? I think it's a bit sad actually that we. So we will listen on 31, 337, just to make sure that we're not like messing their thing up. So let's see. LNP 31, 337. So we're listening on the same box. Though it is a sewage, so we will have other permissions, right? That's the reason we're doing this, to get the permissions. Not to connect to another machine, really, so... But they could have done it another way. Doesn't MSF Venom have payloads that just get a shell? We'll have to test that too, because now I'm curious. Why did they do it like this? And no bad things said about this, right? This one, 0. Now I'm even more curious what we're supposed to read and why this reads 0. Wasn't this what we're supposed to read, and we're not supposed to have read permissions? No? What are we supposed to read then? This is a message we're writing. So we're supposed to read something else. We'll have to look actually, because this is good to know, you know. What are we supposed to read? Okay, road flag. Okay, that's nice. No complaints. Oh, so I'm going to open a third tab just to make the exploit. So now we're doing it. I just didn't copy the out file, so we get the normal text. So my kid's knocking. Well, let's just click that. Yes, gubben. Precis på det, jag bara... Så vill jag inte fräscha den också. Lägg i det alla som verkar funka och se. Det som jag gjorde när jag försökte fixa då, det var att jag gick in och sökte på den modden. Jag gick in på den sidan och kollade på dependencies. Jag måste ju göra det här. Det var det här som jag fick klart fredags. Jag kommer det jag har inte vatten och pannkakor om en stund. Jag måste göra klart det här nu, Laban. För jag har inte gjort klart det här på många dagar. Vilken lack! Jag kanske ska prova göra själv också. So I'm trying to get my 16-year-old to microwave some pancakes in the house. But he's autistic and he's got this thing with cleanliness. So it's tough. We'll see if he does it himself. I don't think so, but we can always hope. Right, so we have the code. We just edit this. So we'll never use this again, right? So we don't need to copy this to any special place. Let's just change the format. So first of all, to skip the annoying hoppiness of it, there, and then we just delete There, so now we have this as one big thing. And what I recently copied to this one, here. Let's copy it again and update it. So let's do it like this, and let's just take this one. So copy and right. So when I created this, let's just double check. I'm 99% sure that it was the same characters. Yeah, I'm 100% sure it was the same bad characters. So we don't have to like update it. Yeah, so I was doing like example 1, example 2, and then I removed it when I realized it was the same. So 100% sure. So these we copy into here, and we could also probably see, right, so it's encoded. It's 95. Right, so this is not correct. We have 256. Yeah, and these are 95. Yeah. Yeah, it's good. There. So, and then 2060 is to the start of this address. This is all calculated to get this at the right point, so it is after this calculation. So we do minus this number and minus this number to get the correct spot here, which is 2060 from our calculation earlier. Let's just scroll up there. Here, this is where it got the segmentation fault. It tried to hop to this address, and this is the position of it. Right, so that's what we're supposed to go to. So this should instead now connect, instead of this one that we tried just a bit ago, and now we're trying to connect to our, I'm like, do I even hear audio? How to test. Let's test. Send a message, see that it works as it should.
Fix it says.
Yeah, good.
Test.
Good. So I have not had time to check my automatic messages either. Apparently something is off. I don't know what could have happened to StreamerBot. There are updates, I know. I haven't updated though. So let's go back. This one is listening on port 31337. And here we're now going to do the run again, but a new one. And this one will connect to the local machine instead. It's still the same address here. The only change is that in this, all the bytes here, in here we have encoded this, our local host IP instead, and the port. So start it from the beginning, yes. So nothing. So we don't have any connection here. Let's just restart it. Let's check this. First of all, we can just do a simple test by changing these all to let's do 55s or 66s. We did 66s before. It's slow when I move my cursor, it doesn't move. There. So now we should get a folder ready at this address, and if it doesn't, we'll have to check. Yeah, so this it's going to the right address, right? And I think we can probably check memory. Yeah, we should probably like do a breakpoint and check if we want to double check. So this should work, you know, unless this would have changed and not anymore be the correct address. But if it would not have been the correct address, then this would probably have been something else. So on this position, that's where it ends up, probably after here. You know, after it's already done its thing. So I'm a bit curious where this is. Let's go back up in the notes, because I don't want to miss anything here. So I know that this is not a like notes friendly bit of it, but here we have where we found. Here is where the shellcode starts. Here is where we start our knobs, and to get this we did set a breakpoint, right? Yeah, so I'm like removing this almost because it annoys me, but it's maybe not obvious. Yeah, going back. Here's MSF Venom accounts. Yeah, I did save theirs too. So let's just delete this because there's no purpose. I'll keep it in the how the command works bit. So this is the other one. I think I tried it too last time. Let's do a quick test, right? So, no, I want to check the address first. Here, we need to have a breakpoint. I'm a bit sad that I don't remember where I put the breakpoint because I disassembled it to find it. I guess I'll have to do it again. Oh, IF. Hi,
Opinion says.
Welcome in.
Hello.
Welcome in. Yeah, so I'm like stuck at the same place here. Though instead of using connect to my machine, which worked last time, now I tried to itself as the example is, but it didn't even pop anything up there. So since I restarted the machine and everything, I'm thinking maybe something goes wrong here. So this is not what I'm going to do. I'm going to set a breakpoint, but let's just do. We probably don't need to do it all. I think IF. No, totally wrong.
Take a 5 minutes break and come back to it maybe.
Functions. Yeah, I've taken 4 days break from it. So that's not the problem. Yeah, so I think we used puts before.
Fair enough.
So yeah, we'll have to disassemble it. So I have this up, checking the this as. So now let's this as main. Is it just slow, or didn't I type anything? Yeah. Sometimes it's slow, so it's hard to know. So if we check the calls here.
I wish I had some idea what you're doing, but this is much more advanced than anything I look at.
Yeah, but I can explain if it's something you don't understand. So this is the main function, and this is the assembler instructions when it's disassembled. And we don't need to know right now much more than that we need to make a call, or we need to make a breakpoint at some position in this so we can look at memory while the program is still running. And that's why I'm checking for the last call in the main. Possibly we should do leave message. We can do leave message. We can put a breakpoint when this function starts running and look at memory there, right? Let's do that. So we can continue the disassembling by pressing return. We'll get the rest of it. We could have pressed Q not to get this last bit. You can also look at my notes, because I have all of these things, right? I have explanations of all the bits of buffer overflow before here. Anyway, we put a breakpoint. Now we can look at memory, and we can use these commands that I have over here to see. So we can use this, for example. So it's just kind of big chunk of memory we're looking at. Paste. Oh, we got an extra character there. So ESP is a stack pointer. So here we can see where our knobs start. The knobs start here, meaning that somewhere here is the address that we want to jump to. We set the address that we want to jump to at the very end here of the command. Here's the address. So we will now see if this is a reasonable address. If CC90, because it's backwards here, it's the endianness of it, meaning that just means it's backwards on PCs. Someone decided that long ago. We just have to live with it. And here is where we see the knobs stop in. Here is where the code starts. So here our code starts, and the address CC something is not in here, right? That means it won't run our code. We will have to put a new one. So we can decide anything here. The only thing that we need to know about this address that we decide on here in the middle of the knobs is that it is not supposed to include the numbers that are not allowed. And we checked these a bit earlier, so we know that. Let's scroll up quite a bit. These numbers are not allowed to be in the address or in the payload, because this will break the string and it won't work. So here now we can see 00 is not in any of these, right? Here we have a 00. We couldn't start with this one. And then we have 09, so no 09s here, no problems. 0A, no 0A's, not a problem. 20, no 20s. We could like take anything except for this one.
Are they like reserved keywords / chars or something?
Yeah, exactly. So let's go even further up the notes here. So these characters, they mean something, of course. That's why they're here. And I made a list here. So a string in C is usually terminated, or it's always terminated by a null character. So if you have a null character in the middle of the string, it will just stop reading there, right? So we'll never get any further. Then there's like, for this one, we tested and saw what characters were replaced by a null, actually, because that's what happened. So a 08, I think it was. I don't remember them down here. So let's copy the bad cars. Come on, I'm blind. There. So let's copy these. So all of these characters were replaced by a null. 00. Null byte. Here. So if we paste these here, let's keep it here as an example. So 09, a horizontal tab also broke this and was replaced with a null in the string in that when we looked at the memory. And 0A is line feed, new line. So the new line was also seen as the end here of this. And also 20, which is space. So you couldn't have spaces in there either. So all of these broke it. Otherwise, all characters were just sent in into the string, so we could just see it in memory. It was still there, as it should be. So that's that. Is it clear? Any more questions? Yeah, and this was a suggestion.
Okay, I understand, thank you.
Tester. Great. So that's why we need to make sure that these numbers, as we're sending this into there, as in the string, you know, in the input string, we need to see that this character is not in there. So let's take another address. This one doesn't contain any of them. And then we need to know that D6 and the E8, also the FFs, but the FFs are the same as before. We need to switch them around. So if I go back down here and we'll look at what we sent like backwards now, FF, CC, and now we want this to be D6 instead. So we do D6, and the last one was supposed to be E8 now. So here, right, D6, E8, and now we have E8, D6, FF. So that's just a PC thing, you have to just remember it, called endianness. So that's all. Now we have a new memory address, and this was the new one, right? I'm like, I better check. What did I send last? Nah, I'm not going to check it. We're still listening on this HTTP machine, on the same one we're sending stuff. So I'm just typing anything to hop to the end. Let's do Q. We have seen where in memory this is. It looks okay. So now we go back to the command here. And now we're going to change these 6s here. Right? So we can do this manually. It's so tiny bit. Things to change. I could have arrowed up one more time though. We have the FFs there. So D6 and I removed the X too. So \X just means this is a hex value, these digits. And E8, every hex digit is 4 bits. That's why you have 4 plus 4. So 2 hex digit is 8 bits. So that's why we have 2 of them for every character. So every character have 8 bits, right? So too many numbers in my head now, right? So there we go. And we want to restart the program. And we do have a breakpoint here, but it died before this. So what happened? This is interesting. I'm actually just going to quit this. I want to quit this. Yeah, so we'll do it all again. And I'm curious to see if it has a new memory address. That's one of the reasons I'm restarting it. So we're running it again. Now we can't arrow up, we'll have to type. So if it, I'm like, I did a break, right? No, I didn't. Yeah, I forgot to. But it works anyway. Because we still had it in memory. So sometimes it doesn't want to, after the program exits, doesn't want to do it. Yeah, but that's when it doesn't break. When its segmentation faults, it still has it available for us. Right. So before I had it actually quitting in a good way, actually not getting buffer overflow because of these break characters, ending the string, making it shorter than it was supposed to be. And then I had to make the breakpoint because of the bad characters ending the string, terminating it too early. So so now we can just run it and we can test stuff. And I'm going to use this last one because I think it's correct, but I'm not sure, so we'll see. I don't want to copy paste more than I have to. So to run, it's just slow. I didn't do anything now. I just clicked it once and then it popped up. Not pasting. So confirming here, we have first character 55 a lot of times. So the number of characters we want to hop into before we type the address. Then we have 256 because we have 256. NOPs. NOP is no operation and it's hex 90. And then we have the actual instruction that we want run. And then we have hopefully the address to these in the middle of the NOPs. So it will just do no instructions until it ends up in the instructions we want run. So that's that. If it works, we did copy the right code, otherwise I'll have to try again. Ooh. So, looky. So this is a new message. This is what we were going for. So apparently I run the same thing after already having something run, and it didn't work. But when I started it again, it worked. So I have to look at memory later, and this process didn't stop. It's still running, meaning we have this. So if we do ID here, we should be wrote. No, we're not. So it is still something off here. This is interesting because it's supposed to be suited and the program is supposed to run this. Bin dash. This feels so odd. Yeah, so I know that this should work really. So if we do ls here, we now have a connection at least, right? So if we were to cat the root thing, we can't do it, right? Because we're not root. So I think it was flag.txt, and it will say permission denied because we don't have access, because we're not root. So this is all logical. The problem is that we're supposed to get root. Come on, let's try again. So let's look at memory now. it exited with code 1. I'm kind of assuming that the memory check command that we used before this here, that this won't work now. But we will test it to see if it works. If it works, this is not logical because it's exited. Yeah, so now it says no registers. So ESP doesn't exist, it's not running. So if I happen to know the address, which we might happen to know, we might just be able to do it anyway. Let's say that we do this instead, right? We have the address that this comes down to. So let's see if it if it's the same. So I'm interested in why it ran that. So let's do X. We want to see hex. We want to see 2000 hex. We want to see it in hex byte format, 1 byte separate. And the address we want to see is, yeah, it managed. It's so slow, so I think, what, did it fail? And it cannot access this memory, which is kind of logical. So we'll have to restart it with the breakpoint this time, because it exited as it's supposed to. So I have to remember how to make a breakpoint. And break function name. Yeah, I almost remember that much, but what was the function name? I just checked it before here. So right, on basic information, to get info functions, we list all the functions and their addresses. So the function like names are just pointers to these addresses. So when we want to disassemble when we disassemble main, then we really disassemble whatever is on this address. But it seems to be able to do it like, it's a bit tricky, because I managed to make it disassemble. That was R2 though, and this machine doesn't have R2, I think. But I managed to get it to disassemble things that were not actually code, just bytes. So, am I blind? Where is it, the function? I think it's like the same name as... something that's not at PLT and is not start. Here, it's just before main. I'm so blind. So leave message. Very, very hard to remember. I think the program name is leave underscore message though, so it's a bit tricky, right? Leave message not defined. So this is funny to me. Why? Let's see. Say yes, and let's try again. And let's just double check. It didn't have. I still want to do R2 now. I feel it's much better. So I could find mine, right? Let's look at main. And it doesn't have any other name. Because in R2 it would have another name. It would have like dot. So, and it should already be loaded, right? And this is a run command. And this is the last memory address. We could just do, I'm just arrowing up. We don't have more in this memory. This is good enough. So, yeah, look. So I would like to look at memory before. This is so nice to see a lot of random stuff happening. Yeah, so how do I find the memory address before actually running it? I have to like break it main.
Panda Tongue says,
Let's break main.
where's your harness at when you're climbing through code?
Hi Panda, hope you're great. So let's break main instead. Let's actually, I'm going to quit and then we run it again. So we have a fresh slate to start at, and instead of like doing anything else, we will just, I think, break main. It can be done like that. Breakpoint. And then when we run it with our, we count our up because it's gone thingy, let's copy. Just copying from the other screen here. So we have this up still. Yeah, you saw me testing that yesterday. I should have like tested a bit before. So really these addresses, this is not the correct address at this point, right? We don't know the address anymore or yet. So we will have to get a new one. There. So we're at our breakpoint. Now we can look at memory and have a bit more control there. Actually, I'm going to copy the memory command to the other screen so I can just easily paste it whenever I need it. And there. So here, paste, and we can see our end of the quite a few 55s, the start of the knobs here that are supposed to be 256, and if we click again we get the code starting actually here. So to do this the same run again, we would use one of these addresses without that doesn't contain the bad cars, and we should be listening here again then. So we did get it working once, but we were not root. So it's a bit odd actually. It feels like it's just jumping around in memory without my control. That's not a good feeling. So here's what the actual exploit is, and it's MSF Venom, and we have copied their command to create it. Then we have, let's see how many. Yeah, I was looking for the 66 or 66. It's hex 66, so it's not 66. 66 implies it's decimal numbers, which is not. So after this bit of memory, this we don't know what it is, whatever, you know, it's outside what we've been playing with. So we put all the way down here. This is what we put in memory. So now when we run this again, so we had D6 E8 should have been an up. So D6 E8 should have been here in the knobs. We didn't run it though, right? So if we quit this one and now we let's clear the brakes, right? I have to check how do I do that? So maybe I don't know how to do that in here. So we don't have to, we can just continue when we get there. C to continue, just continues normal execution from the breakpoint. So if we go back up and we replace this with our memory address, so FFFF, and then we have one of these. Let's do D6B4 this time then. Very similar. So it's slow. D6 B4, right? D6 B4, confirming. D6 B4 is in the middle of the knobs. We have them both after and before, and we run this, and we want to start it from the beginning. Now we're at the breakpoint, so let's actually look at memory now again and confirm that D6B4 is still in the knobs. So D6 B4 here is still in the knobs, right? So we don't have to see more. Now we press C for continue. We should continue execution, and error resetting breakpoint. Function main is not defined. Okay. We got our connection. Let's do ID. And we're still the HTTP student. So this is like just nothing inside my control. Because I think that the program itself is supposed to use the SUID, the permission changing, and when we disassembled it before, I think we saw that using it, right? The functions. Let's scroll up to the functions. I don't know if I showed all of them. Sorry for the long scroll. Oh, we're actually here. No, that's the disassembling. So let's see here. I think I saw something. We should go to the disassembled instead. This is not useful. Set result ID, printf, close, copy, puts, exit. Let's look at the code. So, yeah, set, I think this is what's supposed to do it. So let's actually copy this and Google it, because I'm curious now. So, set real, effective, or saved user or group ID, and this is done here in the code before the call to the leave message. So we don't have to understand all of the details of everything here to see that this looks like it should work, right? We could step through it, look at all of the code. I don't want to look at the code for this. Yeah. So I'm like curious if something is wrong with this. Also, what does it want? It wants the contents of the flag file. Yeah. So it might be broken. It might be broken. It's not like it's the first time that happened, right? So, an unprivileged process may change its real UID, effective UID, and saved set user ID, each to one of the current real UID, the current effective UID, or the current saved set user ID. Privileged process. Cap set UID capability. And this is a real SU, it is not the set UID capability. Regardless of the changes. So I think this is what's supposed to give us the permissions that we don't have. So since the connection works, you know, it's not like I can rewrite the program because we don't have high permissions on this. So let's quickly see. So HackTheBox. See if anyone else had problems. And it's buffer, overflow, and let's actually copy the ID string, because if someone else had problems, they probably wrote this, right? I got this instead of root. So this is from the forums. Is this the same one? I'm getting a shell. HB student, please help. Finally rooted. So they continued. They got this first, and then they got this. So they managed it. I also got stuck on this. I followed all of the stuff that was taught in the tutorial I have been reading and watching. Did you get a reverse shell? How? With this reverse shell, what user are logged in as? You know how sticky bits work, right? Find the file with the sticky bit set. Okay, okay. Okay. Is this for exactly the same? Yeah, thanks,
Kitty
Nori.
says.
That's great.
Odgaverja 14 Noiki Wanyu.
Translated from Indonesian.
Okay, so you're speaking Indonesian and that's English? I guess I'll just have to think more. The thing is that we had like a very similar thing, but not the same, right? So they expect us to think. I didn't think they expected us to think. Find the file with the sticky bit set. Remember when you're inside GDB and run the same as executing the script with the parameter as follows. So let's see what the next one says. You can only debug a setuid and setuid program if the debugger is running as root. The kernel won't let you call IP trace on a program running with extra privileges. If it did, you would be able to make a program execute anything, which would officially mean you would. Okay. Alright, so we're not actually supposed to run it in there. Yeah, I think since... Didn't it change its memory address today? Just now? Every time I restart GDB. So how would I then do it? This is just a general question. So 124 is just a random number. But it's a bit messy. We could just have all of these spin-ups. We don't really have to have any 55s. I think you know... Yeah, you're already in the machine. So I think I remember that there were no other files there, but maybe I should look at the directory. Right. Yeah, so since I had this problem last time and I didn't remember the thing at all, really well, I remember bits. I did, before leaving work, while I was working, I checked the end of a YouTube video on this. And they did exactly what I did. And the only difference from what they did, what I did, that they did it on the machine, and I did it to my machine. Alright? And we do have a connection now on the machine. And they were root. So that's how this started, at least. Maybe it's not that like that anymore. But let's see if there's anything interesting here. Multiple ways, including this. Leave a message. What? Why would they do that? So the person who didn't find it found it finally. Someone probably said congrats or something. Or give me a hint, of course. Yes, I guess we should just see it as a normal box. Yeah. Think outside the shell, not outside the box or anything, outside the shell. Okay. So my problem with this is that it changes memory addresses. So when I close it down, it changed the addresses. So we're still connected to the machine. I guess. So I didn't really look at that video very closely. I just know that they used Netcat to catch it. So they used the thing, right? They didn't do something completely different. So if we LSLA here, just to make sure I didn't forget, we just have these files, right? And leave messages owned by root. So this is what we're running to get this shell. And just UID. And I thought from reading maybe I shouldn't have disassembled it. Maybe that's just confusing. So let's just listen again and just run it outside of GDB with the same command and see what happens, right? So let's just copy this here. So, and actually, yeah, I guess I'm quitting this again, and then we're LSLAing because what was the name? So leave message, paste. We're running this outside of GDB with the same memory address. So I don't think it even ran it, did it? Okay. So this surprises me because it changed the memory address, right? And now it worked. So now we have root there. So meaning we can read the file. So I have to go up and look. So okay, so SUID, what they said really in the text, what I read in this, they said you can never use a SUID within GDB. That's what they said, because then you would have problems, right? But let's see here, memory address. Let's look here. So here we're at, yeah, so we're at D6 already. So it's when we reset the box, that's when we get a new memory address. So as long as we're in the same session, D6 and D6. So as long as we're in the same session on this specific HB machine, we have the same address. Even if we run it, even if we restart GDB, if we run it in GDB and outside, because I have different experiences when running this. So, but the GDB thing is a big thing to note down. And I'll have to reread this, what they wrote, and I have so much training ache. It's crazy. Oh, I hardly can work today. And also, I usually can bend my arms more like this. It's so the indoors climbing was really good training for me.
Moved big stretch.
Yeah, no, I can't stretch a thing today. So let's just cat this thing so we have that down first. Flag.txt. So I'm going to copy this. But I want to know more. I want to check this out. We want to make sure that we have this in our notes. So let's go to the... Let's close this one. So let's paste here. Yeah. So why should these stay forever? So before we continue, I guess we could click finish. Because it doesn't have anything to do with the room. We want to do the Windows one next, but first I need to know details. GDB set UID. No, just UID. UID program. So so annoying. Just because it's Unix stuck in Chicago. We have to do that again. When I did shell and execute it out in shell, GDB. However, when I do a GDB, it starts the process as normal user. Yeah, and launches a user shell. This is the whole thing that we're exploring now. So, you can only debug a set UID or set JID program if a debugger is running as root. The kernel won't let you call ptrace. This is exactly the same text on a program running with extra privileges. If it did, you would be able to make the program execute anything, which would effectively mean you could run a root shell by calling a debugger on bin su. Right, because su has suid set, so there's other stuff required to actually use the suid. If you run GDB as root, you'll be able to run your program, but you will only be observing its behavior when run by root. If you need to debug a program when it's not started by root, start the program outside GDB. Make it pause in some fashion before getting to the troubleshooting and attach the process inside GDB. So we need to test stuff. I have to take a short break. So we solved the problem. We know the reason. But we don't know why it didn't work. Well, I guess it's just this box, Nix buff 32 skills, that can't connect to another machine using this. It might work now though. We could try again. We'll just make sure we have notes on this, and try maybe the attach. And let's just quickly check the time. But I just have to go to pee. What happened? So when I finish it, did it stop the box? No, it's still up, and we have 41 minutes, so I can go and pee. I have to get some pancakes for my kid too. Yeah, I will actually one thing at a time. Jag ska fixa till dig nu Labban, ska du se. Oh! Pizza time. Ja. Oh, det kan bli mer hjälp med det. Det här blir lite här. Okej, jag hjälper dig. So seriously, this training ache, like pulling your pants up. that's the worst part of, climbing like this. So there's also like training ache on the outside edge of my hair, actually around on the top. I'm like apparently not very used muscles. I also have a tiny bit in my breast muscles, but that's like muscles you use, right? I'm just going to switch mic and I'll go and get some pancakes for him. Then we'll explore this and we go Windows buffer overflow. So
Opinion says.
Hi Nori. No sound, fix it.
So this mic must have disconnected then. So that's odd.
Fixed it.
Fix it says.
Test.
Opinion says.
Name checks out.
Yeah, but I hope to fix more things than that. Yeah, so I'm thinking, since there needs to be a way to pause a process to be able to attach to it and put it connected to GDB, and this program is simple and it just takes input and then it crashes if it doesn't get input, so there's no way to pause it, and the input is the only thing that's happening. Command line input. So I don't think there's any way to pause it. So I think we'll have to survive not testing it and just adding this to our knowledge base that this is how it works. And let's go to the notes here, and I have added it here. Attach process ID, and here let's fix this. So this is important. But I want BRs here. So let's actually do all the lines, I guess. So you can only debug a setUI or setted program if the debugger is running as root. Otherwise, you could just call GDB. I think for is the best alternative, and have root on. Yeah, on. Let's do on. Come on. So apparently I couldn't edit it in that mode. So the font tag makes it not as editable. If you run GDB as root, you will be able to run your program, but you'll only be observing its behavior when run by root. If you need to debug the program when it's not started by root, start the program. Yeah, and I didn't get the source for this really. We want to have our sources because I don't want to steal people's stuff, you know? That's mostly why. It's not like I don't care about sources like that. Good information is good information. I recently closed tabs. I think it's this one. No. History. Is this the one? Yeah, Unix. So let's just do from. So there. I edited a tiny bit here to get rid of some text, but I think it's all interesting anyway. Or we could just skip 2 lines at least. It's still too much stuff here. So it's simply so we don't have to read this if we're not checking this, right? Actually, it's supposed to be SG. ID. Set user ID, set group ID. So, yeah, I think I'm good with this one. It's okay. It's okie dokie. So, oh, right. I have to click finish again because I overwrote the history where we ended up in this room. So what happens with continue here? But I've done this. I don't get it. So what's dashboard? Uh-huh. But this one has a continue too. So why does this one have a continue? Is it because of this one is not checked? To me it looks completed. Oh. So I did not click that button. So now it has a view instead of continue as this one. So now we want to do stack-based buffer overflows on Windows. And then we have to unlock this. I don't know why this one is here, and I don't know how to remove it. If I click it, can I remove it then? Oh, it's a part of this thing here. So I did not want to enroll into this, really. So what if, can I go back to the dashboard there? No, this is not what I wanted either. But it says that this is completed now. So let's just search for buffer overflow windows. I don't have 160 of these. These are the free ones. Stack-based buffer flow on Windows. So, if I put Windows in here, it didn't find it. I did click. So we're in the Windows one now. Yeah, and this is why I had clicked this to test, see what happens. I thought it would say you don't have this money, but it didn't. It just popped it in there. So if I unlock this now, and it asks me, do you want to unlock for 10? We have unlocked it for 10. And then I think we will get those 10 back when we finish it. So it's free. So I guess I will read this. Windows binary exploitation has advanced through the years, from basic stack overflow techniques to advanced security bypass techniques and heap exploitation, to reach a level of understanding that enables us to successfully exploit even the most advanced application. We must have a firm grasp of the fundamentals of Windows binary exploitation, which is the main aim of this module. It's the first step on Windows binary exploitation. It will take you through the following. What is binary exploitation and buffer overflows? How to debug Windows programs. Basics of local and remote fuzzing of Windows programs. Finding and using return instruction to subvert the program execution flow. Okay, message.
Multinational conscription says.
Cheap viewers on. Web link.
Yeah, I
FixerBot
wish I
says.
could make the
Message
TPS
removed.
not read it. Oh, I'll talk to Security Live and see. Crafting malicious payloads and scripts to gain local and remote control through buffer overflow vulnerabilities. Developing a functional multi-tier Python exploit for stack-based buffer overflows, which can be used as a basis for other buffer overflow exercises. Throughout the module, we'll be attacking two different programs. First, we generate a malicious WAV file that exploits a buffer overflow vulnerability in an audio converter to perform local privilege escalation. Then we'll move toward remote escalation by attacking a remote server to gain remote code execution over it, after debugging the vulnerable binary locally and developing an exploit. In addition to teaching the above topics, this module will also cover a short history of stack-based buffer overflows, a real-world example of this vulnerabilities, the process behind developing a stack-based buffer overflow, fuzzing the program's fields and parameters, identifying the exact offset of our input's location within the buffer, controlling the address of the return instruction. It's like the same stuff, of course. Identifying and eliminating potentially bad characters, learning multiple methods of finding and utilizing return instruction to subvert execution flow, generating shellcodes and executing them through the return instructions, listening port gradually to identify the length of our buffer precisely, adapting our local exploit to attack remote ports. I don't know what this means. Crest CPS CRT related. Whatever. This might is broken down into sections. Yeah, so let's just continue. So they suggest us doing intro to assembly first, and I'm not going to, but I might later. If it's very intro, maybe it's not interesting. But if it is not, how would you know? Is it free? That's the only thing I care about. I don't want to pay stuff if it's... You kind of need to know stuff about what they are, right? So let's actually duplicate the tab. I don't want to type if I don't have to. So if we paste this, it found it. So is this a free one? Here, how do I see this? Is the only way to click the actual button? It looks kind of basic, but like libc functions. Coding techniques? Yeah, why not? There's a YouTube here too. So what happens if I click here? Will it like automatically do anything? So this is 40. Yeah. No, it's 100 even. We have 40 too little. So that's a no. So I don't understand this way. You know, if it was like a subscription and you could just access anything, then I would pay for it. I would probably get them more money than I don't want to give them from buying stuff like that. I don't know if it's good, you know. If I click something, find it's bad, and I have paid specifically for that, then it's like money thrown away. If it's a subscription and parts of it is good and parts bad and I can just click and see whatever, you know, then it's more free and I can decide what I want to do myself. So just checking time, and I need to eat something later. When should I eat? I'm thinking I'll save time if I eat. I'll probably just. My kid took for breakfast actually this Thai cube, frozen Thai cube, and I'm like very. I was like, So I want one too. So I was thinking dinner. It's a bit too early, but I'm leaving for training at 18, so yeah, maybe 1.5 hours or something. Buffer overflow, stack-based buffer overflows on Windows x86. Let's actually do a marker here. 2 hours. Oh my. You'd think I'm really tired. I'm not. I'm not tired at all. Buffer overflow. Binary exploration is among the most essential skills for any penetration tester. It's usually the way to find the most advanced vulnerabilities in programs and operating systems and requires a lot of skill. Over the years, many protections have been added to the way memory is handled by the OS kernel and how binaries are compiled to prevent such vulnerabilities. Still, there are always newer ways to exploit minor mistakes found in binaries and utilize them to gain control over a remote machine or gain higher privilege over a local machine. As binary and memory protections become more advanced, however, so do binary exploitation methods. This is why modern binary exploitation methods require deep understanding of assembly language, computer architecture, and fundamentals of binary exploitation. Both assembly language and computer architecture were thoroughly covered in Into the Assembly Language module and the stack-based buffer overflow on Linux module. Also cover the basic of binary exploitation on Linux. Yeah, so we haven't done this one. It costs money. This one was free and we just finished it. So buffer overflows in binary exploitation. Our primary goal is to subvert the binary execution in a way that benefits us. Buffer overflows are the most common type of binary exploitation, but other types of binary exploitation exist, such as format string exploitation or heap exploitation. So these are links to Wiki and OWASP. So let's open them, but not read them now. A buffer overflow occurs when a program receives data that's longer than expected, such as it overwrites the entire memory space on the stack. So stack, I guess, is also Wiki. Yeah. This can overwrite the next instruction pointer. Next. Well, actually the old, I would say. Or RIP. EIP or RIP. So 32-bit name, 64-bit name, which causes the program to crash because it will attempt to execute instructions at an invalid memory address by forcing the program to crash. This is the most basic example of exploiting buffer overflows, known as denial of service DOS attack. Another basic attack. Oh my. Is to override a value on the stack to change the program's behavior. For example, if an exam program has a buffer overflow vulnerability, you can overwrite the buffer enough to overwrite our score. Since our exam score is stored as a stack in this example, we can take advantage of this flaw and change our score. If we are a bit more sophisticated, we can change the address of EIP to an instruction that will execute our shellcode, as we just did for Linux. This would allow us to execute any command we want instead of just crashing the program, known as jumping to shellcode. Okay. With more advanced memory protections, it may not be possible to load our entire shellcode and point to it. Instead, we may use a combination of instructions from the binary to execute a particular function and overwrite various pointers to change the program execution flow. This is known as return-oriented programming. raw attacks. Finally, modern programming and modern programs and operating systems may use the heap instead of the stack to store buffer memory, which will require heap overflows or heap exploitation methods. And hopefully we have more information on that here. So where were I? Okay, so it was all of that. Stack Overflow. Let's start by demonstrating how stack works in storing data. The stack has a last in, first out leaf for design, which means that we only pop out the last element pushed into the stack. We can push an element into the stack, it will be located on top of the stack. If we pop anything from the stack, the item located at the top of the stack would get popped. The following table demonstrates how the stack works. We can click on push to save a value from EX to the stack and pop the top value from the stack into EAX. So why do we have empty? Because they want to show us and fill stuff up. So we've just been doing this a lot. I'm thinking, should we hop stuff? I guess I'll just read it quickly, right? Oh, we can actually use it. So let's push 1, 2, 3 onto the stack. Let's push 4, 5, 6 onto the stack. And then we pop and pop and pop and pop and have nothing left. We better put something on the poor stack. This is nice to have actual running examples, right? This is like BB level, or is it? The above example correctly receives buffer data, such that it never gets overflowed to the next one. I should probably read more carefully. The above example correctly receives buffer data, such that it never gets overflowed. Okay. Yeah, so if we write a mega long one here. Okay. It always pops on to the top. So what if we like fill it all up? What will happen then? Yeah, I can't do anymore. I had to try, you know. The following example explains. Example expects an input from us in 8 characters long. What would happen if we send it longer? Try to send 20 characters. So, okay. There. Push. So, as we can see, when we send a string that is longer than expected, it overwrites other existing values on the stack. I would even overwrite the entire stack if it was long enough. The problem with this is, let's reset it and let's do a long one again. So, okay, so it did it the right way. Good, yeah. So it was good. I hoped so. But in my corner of my eye, I didn't really look carefully enough, apparently. It didn't seem like it did it, but it did. Most importantly, we see that
Cybernair Dante says,
Hello. Happy Tuesday.
The same to you. Happy Tuesday. Hope you're having a great day. And that you're great. In great shape. So let's continue reading. So this is repetition since we just did the Linux one. So we're doing Windows now. Windows. does not, let's see, most importantly, we see that it overwrote the value at EAP. And when the function tries to return to this address, the program will crash since the address does not exist in memory. This happens because the LIFO design of the stack, which grows upwards, while a long string overflows values downwards until it eventually overwrites the return address EAP and the bottom of the stack pointer EBP here. This was explained in Intro to Assembly Language. Okay, so this was a paid module, so we want to look at that. If no one tells me, it's great. If someone does that, I might. Whenever a function is called, a new stack frame is created and the old EAP. So I have my own text on this already. Gets pushed to the stop of the new stack frame so the program knows where to return once the function is finished. For example, if our buffer input overrides the entire stack and return address EAP. I am thinking, is this better than my explanation? Then I might update mine. I don't think so. It's an example though. An example is always good. So, if our buffer input overrides the entire stack and return address EIP, then the overridden EIP address will be called when the function returns due to a ret instruction. I think mine's better. If we calculate our input precisely, we can place a valid address in the location where EIP is stored. This will lead the program to go to our overridden address and when it returns, first the program execution. So let's just hop over here to buffer overflow, and I'm thinking I'll need to edit the end of this, right? But here's really, I think this is better. But I also have text explanations, but I'm not opening in all of them on my... Come on. So, was there something else minimized here? I'm just trying to find the header. There it is.
VR
Oh.
Mechatronics says.
Web link.
There. Look, this is rain water. Sure, okay. So let's look at rainwater. Oh my god, sorry people, have I been zoomed in? That was not on purpose. I have to change. It was when I was typing all the numbers, right? Oh gosh. Yeah. A lot of rain. Lots of rain. I think they forgot to stop filming. Yeah, so the other day when it rained a week ago, too, when I was out in the rain, then while I was just a few minutes, the water increased like 20 centimeters on top of the bridge that was already overflowing when I went one direction. So
It
was
started raining
quite
in
a lot
southern
that day.
Poland.
Yeah, that looks bad. So here we didn't have anything that bad, at least, but it was raining a lot. So weather is a bit out of control now, really. Yeah. Let's continue reading. I want to focus and get some studying done. This would lead the program to go to our written address. Yeah, I read that. Real world examples. There have been numerous incidents where Stack Overflow exploits were used to break into restricted systems like mobile phones and gaming consoles. In 2010, iPhones running iOS 4 were jailbroken using the Green Poison jailbreak, which utilized two different exploits to gain kernel-level access over the iPhone and install unofficial unsigned software and apps. One of these exploits was a stack-based buffer overflow on the iPhone's HFS volume name. Ooh. At that time, Apple did not automatically randomize address space. iOS 4.3 patches vulnerabilities and introduced memory protections like randomizing address space layout randomization, ASLR, a stack-based overflow exploit, who also used a high gain kernel level access on the original PlayStation Portable PSP. So that's too new for me to know anything about it. The original, I was like, original? Are there several versions? This allowed the use of pirated games as well as installing unsigned software. The TIFF exploits a vulnerability around the TIFF image library in the PSP's photo viewer. This leads to code execution by simple viewing malicious TIFF file in the photo viewer and setting the background to a corrupt PNG image. Ooh. Another similar attack, stack overflow exploit, was later discovered in a PSP game, Grand Theft Auto Liberty City Stories, which had an overflow vulnerability in its saved game data that can be exploited by loading a malicious load file. So how many examples do they have? Okay, there's one in Zelda and PlayStation 2, free DVD boot. Yeah, so we don't have to read all of this. My god, someone liked games who wrote this. all console examples. Of course, operating systems like Windows, Linux, and Mac OS were always the first target for stack-based buffer overflow exploits. There have been numerous such vulnerabilities found in all of these systems and software running by them. By detecting these vulnerabilities before products go to production, we will reduce the occurrence of potentially catastrophic pitfalls. Stack overflow protections. Yeah, so let's go to that in our notes. So what I would like to have here, let's see if I can just open all of these without messing up. So this is not closed, okay? I would like to have like headers on this side. And we might actually make such an add-on to Obsidian if no one else does, because I want it. I want to be able to see underneath my buffer overflow. Where is it? Not Linux. Here. So under buffer overflow here, I would like to see the headers. Like in Google Docs. You can see the headers, you know, on the side. I would like to be able to see that. So that I wouldn't have to go like, what is buffer overflow? Reddish memory layout, stack frames. Where did I put these nodes? Program following assembler. Did I put it in a separate file? Yeah, it's in modern security features. So that's why I didn't find it. But still, I would like this function to have that.
Kitty says.
Buffer overflow is easy to understand in the speedrunning game world.
Okay. So, how do you use buffer overflow in speedrunning games? I should drink this because I'm hungry. So, apparently we had water overflow. So buffers in all kinds of things, including real world. So these are the notes so far on this. Disabling security features for testing there. Right, so did I have the compiler ones here too? Yeah, they're here. Compiling away and then disabling for testing. Right. So let's read this. As we may notice from the above examples, most of them are pretty old, aging back at least a decade. This is because modern operating systems have many protections for the stack, like preventing code execution or randomly changing the memory addresses. These protections make it so we can't easily run our code placed on the stack or pre-calculate the memory addresses to jump to. However, even with these protections, if a program is vulnerable to a buffer overflow, there are advanced methods to bypass
If you wish to be
these
interested how
protections.
buffer overflow works in games, web link.
Okay, sure. I can watch later. Oh, yeah. So that looks like something my kids would like. I'll look later. Thanks, Nori. Even though I didn't have any snacks. Yeah, so hard to pre-calculate memory that is to jump to. However, even with these type of predictions, if a program is vulnerable to buffer overflow, there are advanced methods
I had
to
snacks
bypass
before I
these
came,
protections.
because I knew you did not have any for me Noiki one cry.
Yeah, I'm trying to be healthy. I don't have any snacks. If I had snacks, I wouldn't be healthy. That's like a very clear thing, right? Some examples include the previously mentioned return-oriented programming ROP, or Windows-specific execution methods like egg hunting or structured exception handling exploitation. Right, so there's not any more information about this, right? So advanced bypass methods. We need to have this in our notes, and we don't yet, so we have to fix it. So I copy stuff and then I type it. That's not smart. I can just at least use one of the words. So Windows specific. Alright, I should have hopped an extra there. So both of these are Windows specific. So let's see, what level header should we use? 3. And to add, because we don't have enough information. This is just, we need to add stuff, right? Now I want snacks, Nori. Can you get me some snacks, please? Digital are okay. They're okay. Furthermore, modern compilers prevent the usage of functions that are vulnerable to stack overflows.
I got some crackers and rice cakes, only plain flavor.
Oh. At least salt, right? Thanks. So the compilers themselves have safety features, and these are what we're disabling here with no stack protector and no PIE and exec stack to be able to execute stuff on the stack. So we had to do that to be able to run stuff. So I guess it's good that it's secure now. Of course it is, right? Less fun stuff to play with though. But it's good for, you don't want people to hack your computer, right? So yeah. Which signifies the occurrence of reduces the occurrence of stack-based buffer overflows. This is why stack-based overflows are less common these days. At the same time, other more advanced types of binary exploitation are more common, as they can't be mitigated by simply enabling a protection method. We learn basic stack overflows. In this module, we'll learn how to, my god, 2:30. I've been 30 minutes on this page. In this module, we'll learn how to gain code execution through basic stack-based buffer overflows. We will do so on applications and systems that do not have any memory protection. Otherwise, we require more advanced methods to gain code execution. But if basic stack-based overflows are no longer common these days, why should you learn them? We do so because learning them gives us a good understanding of the basics of binary exploitation and the fundamentals of exploit development. Furthermore, once we master how to detect and exploit basic stack-based buffer overflows, it will be much easier to learn structured exception handling, which is very common in modern Windows. So I'm like, what? Finally, once we get a good grip on basic stack overflows and basic mitigation bypasses, we would be ready to start learning advanced mitigation bypass methods like ROP and other advanced binary exploitation methods. So what was on the right side here? Did I scroll past something? Just a list of what we're going to do, I guess. So there's a cheat sheet. I wonder if the other one had a cheat sheet. What happens if I click here? Oh, so it's like hops up stuff on top. Okay, now I'm too curious to do anything else but to duplicate and go to the last one. So if we go to the dashboard, can we still see the old one? So this is in my favorite list. So modules, all modules. Here we can see all modules, I assume. So owned modules should probably be these three, right? And here I can see that these are finished. I can remove this. I can click this to look at it again. Right, so we're learning how the HTTP Academy works. So there is no, was it cheat sheet? No cheat sheet on this. So if we were to hop in the middle of it, there's go to questions. What's questions? Oh, of the page. Meaning this cheat sheet thing is for this page. So if we go back, we don't have a cheat sheet. We do have a cheat sheet. So it's all for all pages. So Is it the same here and there? Have to explore. So we have Python, ERC, X32. That sounds interesting. Yeah. It's the same for all of them. So, I guess we'll copy this. Overflow steps, commands, and you can download it in what format? PDF. Oh, we prefer text. Text you can copy and paste. So, as we can't, you know, have 2 long documents here, I'm thinking of splitting this one up. So let's just make a new note with HTTP buff Windows sheet there, right? So it's all here. It copied okay. So I'll just hop back here. But I really want to have that one up too, because it sound, oh, middle click, not right click. So let's have that up. So we won't have to go back to this page or something. So this looks interesting. So we already have new stuff. So where do I have tools? I guess you can find it by searching here. So I have WinGBG and Immunity Debugger that listed here, and they have IDA Pro. Either outdated or need a pro license to use. Okay, yeah, outdated. This is my problem with the Try Hack Me room, and here they seem to have like, so we can't use this, it's too old. We'll see. Welcome in.
FixerBot says,
thanks for the follow.
New follower ST4com. Less than 3.
So we just did the Linux one, now we're doing the Windows one. So I'll read this, and when we find interesting stuff, we'll put it in the notes too. Debugging Windows programs. To successfully identify and exploit buffer overflows on Windows programs, we need to debug the program to follow its execution flow and its data in memory. Now, there are many tools that we can use for debugging, like Immunity Debugger, and this one that I didn't know, OllyDBG, WinDBG, also the links, right? Let's actually open. However, these debuggers are either outdated or need a pro license to use. And we got a Immunity link didn't work very well. Is it too outdated? Yeah. It was that outdated. Maybe just a spelling mistake. I don't know. I probably have a link already. We could Google if we wanted to. In this module, we will be using 64 dBg. So x64 dBg. So it is at least x64. An open source user mode debugger for Windows, optimized for reverse engineering and malware analysis. And we don't know yet if it's GUI. It is. And it has dark mode. Oh. Oh, that's better. And hopefully you can set the size of the fonts. Right? I'm assuming if it's modern, you have size for fonts. Right? So let's actually look at this one first. I didn't look at this one. Okay, so 2014. So, and it's 32-bit. So we could just say bye-bye to that page. Or should we add it as a old one? Win GDP. So when I was at GDP's page, I read something about like there being planned
VR
different
Mechatronics
versions.
says.
Assassin's Creed 1, 2, 3 are for €2,50 on Steam.
Okay. Yeah, so my hubby plays those. I think. I don't really take time to play games. I think this is more fun. This is my games. Sometimes I play mobile games, but I think it takes too much time from my life, so I just deleted them all again. I don't even have a card game. I do have practice like languages apps still. But that's learning. That's another thing.
Cybernair Dante says.
RuneScape is the best game ever.
Okay. Yeah, so I do get all the free Epic games in case I would want them, you know, later and want to play something. And I get them for my kids too, since they're free, you know. If they're too bloody or anything. But what I do have,
VR Mechatronics
I have
says.
Raft installed. And
I don't play,
something called
but I collect
Eidolon.
collections of games on promotions.
Okay, you don't play the games. Yeah, so I haven't really played games for some time, so I'm just going to open up TTS and OBS again so they don't fall asleep, or rather I want to see what screen I'm on, what I'm sharing on OBS. So IDA Pro is paid, but there's a free version, right? But it's not useful. I read this as it's not as useful.
If normal price is $19.99, I grab minus 90%.
Yeah, but it's not very economical if you never play the games, you know. If you don't play the games, then you just throw money to nothing, right? That's the thing. So, but if you're thinking like, oh, I'll probably want to play this game, but then if you haven't played it after 20 years, will you play it? So it's all prioritization. Do you prioritize playing games, or do you prioritize like watching a Twitch stream maybe, or while maybe working on something, or maybe studying something?
But I
like
can share it in
do?
the cloud with friends when they want to play.
Okay. Yeah. Then you're doing like a community service there, buying the games for other people. Yeah, if you can share them as a family thing, then you put your friends in a family group on Steam. So I do that with my family. No one else.
Yes.
Yeah. You have to give them your password, right? Or log in on their computers as you, of course. So peripheral disassembler, I never heard that the bugger. But what about the free? Let's see a comparison between free Binary tool. So what's included?
I have already bought 280 games for
Debugger?
10% of their value.
Oh my god. So what is the price? What have you paid for those? For me it's like not worth it. It's all what do you like, you know, but so we can analyze 32-bit and 64-bit applications. It has local debuggers, cloud-based decompiler. I guess that it's like not a server thing. I don't know what the difference is.
Around 1,000 euros.
Yeah, that's a lot of money really for even if it's 10%, right? Don't you think? Yeah. It all depends what you think is worth it. Anyway, yeah, I was thinking they must have a comparison. So, debuggers, local and remote. Free, local. File format. Okay, so this can't take a lot of formats. That's a limitation. Oh, yeah. So that's the limitation, and it's mostly x86. Or only the compiler, it says. Yeah, and of course it's always better to use, you know, open source stuff, free stuff. Always better. But I'm curious what the difference is and why they didn't use this. Because I was curious, you know? So I just put it as a question mark here, but I thought this probably can be used. That's why I did it here, in a parenthesis. For Windows there are... so let's actually fix this one here. But I'm going to read more first, and then when we know what we like, we can add this. But I also have this, you can see, with Linux ones. I have stuff I don't use a lot in the list anyway. So I guess we should add Oli DBG. Yeah, so these are outdated. I guess we'll add it here. So it's there. I didn't type it the same way though. So let's just see. Yeah, I'll read those later sometime. So this is what we will be using. x64 DBG. Of course we need this in our notes. A modern choice. Question mark so far. And I think that we do this. x64 DBG. Is that right? Yeah. So you can always Google if you don't have the link, so it doesn't matter really to put them there, but anyway. An excellent Windows debugger aims specifically at binary exploitation and reverse engineering. Open source tool developed and maintained by the community, and also supports
I'll send you a
x64
VR treadmill and a
debugging.
headset so you can play VR games on stream.
Oh yeah, do that. That would be cool. I don't know if that has a space though. Yeah, if you could do that. But you have to build it first, right? So how is your invention going, VR? You'll have to tell me. Give me an update. Unlike immunity. Okay, so immunity only does 32-bit. That's good to know.
I have 2 prototypes already.
Oh,
Kitty
cool,
says.
cool. Nora is
I'm trying
interested
to
in
fix
that.
something in Unity for VR chat, so I open script to fix and I am greeted with, header, do not edit anything in here, or you may make it worse. It's already broken, so how can I make it worse, Noiki Wanyuru?
I'm sure you'll fix it, Nori. But you two have both VR's big interest, right? Nori, you said you're always in VR chat. You do a lot of stuff. And VR Mechatronics is building, yeah, as you said there, a VR treadmill, so you can actually like be in there and jump and all the things. You said it sounds cool. So you'll have to send it to Nori instead.
VR Mechatronics
Climbing,
says.
yeah, climbing.
Yes, climbing.
Cool. So, immunity debugger only does 32-bit. So we can keep using the DVD, x64 DVD. When we want to move to Windows x64 buffer overflows. In addition to the debugger itself, we will utilize a binary exploitation plugin to efficiently carry out many tasks required for identifying and exploiting buffer overflows. Yeah, one popular plugin is Mona Pi. So I think this was in the Immunity Debugger stuff we read too, which is an excellent binary exploitation plugin, though it's no longer maintained. Does not support x64 and runs on
Kitty
Python
says.
2.
If I did more stuff in VR, I would be skeleton lol.
Yeah, you. But VR, have you checked out Nori's streams? Let's do a shout out here. I don't think VR streams, but you do, Nori. So.
VR Mechatronics says.
I need to find some escape room. I want to install it there.
So there, everybody. Nori does very cool VR DJ streams. Yeah? So go and listen to the music and look at all the cool graphics. And they build like, yeah, cool disco rooms and stuff. You can tell, Nori. So, there. Yeah, so apparently Mona is ancient. Python 2. So instead we will be using ERC.
Kitty says.
Do not have much on Twitch no more. We no longer allowed to clip or record Noiki one cry.
Oh, yeah. So you stopped? Did you stop? No? Oh, that's sad. But then you could just hop to YouTube and stream on YouTube instead. If they allow it. I hope so. So instead we will be using, which is an open source binary exploitation plugin.
No, it's against Twitch toes if we stream music or VODs, and clips must be disabled.
Okay. Yeah. But you can still do it you can do it live, without VODs and clips. But I understand that that's a bit sad. Yeah.
Yes.
But don't most people like just join in and see the live stream? Anyway. So maybe you could like do stream to YouTube at the same time and they're saved at YouTube? Or will they get strikes there too? I don't know if YouTube is tricky with that. No idea. So let's just double check this because I read it in so many bits.
Strikes and bans there too. YouTube hates live DJs because cannot monetize live.
Yeah, understand. It's tricky.
But we pay music publishers to stream on Twitch now.
Yeah, so if you pay, why couldn't you just keep it up? That's odd. That's odd. So I thought that would be a good thing with the DJ thing first, but then it sounds like it didn't go very well.
VR Mechatronics says.
I built 2 prototypes in the basement, and I have nowhere to test it. I need to rent a living room somewhere.
Okay.
Kitty says.
Live music has different rule than recorded is confusing Noiki one cry.
Yeah, that's sad. I hope you can get it fixed. I mean, you're not alone in this situation, right? There's a lot of people. So, in addition to the debugger itself, we will utilize binary exploitation plugin. And then it says one popular, but then it says it's bad. Right? So it mentioned it and says it's bad, and then it says we use this. So people will know that this is not good anymore. X64 DVG plugin. Okie dokie. Installation. All of these tools are already installed on the Windows VM found at the end of the section, which you can connect to from the pawn box with the below command. And it keeps putting my name here. X3 RDP. Yeah. So it tells us how to use X3 RDP. You can also use the same command in your own Linux VM to connect to the Windows VM. Alright, yeah, so I won't use this, of course. RDP, the Windows or Mac OS. To connect to the VM from your machine, you must first connect using VPN. To install X64DVD, we can follow the instructions as shown. Yeah, so let's just read the section I skipped. Yeah, so it ends this section with it's also possible to install on your own Windows VM. Of course. So, I'm kind of thinking it's very warm in here. Should I open the window for a bit? It might be noisy. Just a sec. Oh no, right. I'm reorganizing my clothes. So I'd have to reorganize them done before I can open the window. I'll just open the door a bit. Oh, gosh. So it's about 1.5 days since I got the training ache. And it's getting worse. So I'm going training later. We'll see how that goes. Like, if I can't lift my arms, I can't do much martial arts then, can I? To install, follow the instruction on its GitHub page, and we have it up already. Go to the latest release page and download the snapshot snipset. Let's look at this. So we have releases. So this is what it looks like at that. Oh no, I smell the piece again when I open the door. Download snapshots zip. Once we download, we can extract the zip. Extract it somewhere. Move it to program files. Why would I want it there? XCBD comes to separate applications. Okay, so they're separate for 32 and 64 bits. And this is the 32-bit. So it's kind of obvious that you download this. I don't need to make notes. No, I can't click the image. Tip. So when you start it, it creates a desktop. The tip to use option theme dark. ERC. To install the ERC plugin, you can go to the release page. Big surprise. So instead, we go to the release here. And there's a zip file. Let's actually put this in the notes. So with the plugin, I guess it's called ERC, but let's actually copy the full thing. So why? Okay, so these are links and these are URL links. So these are links within here to a document. Right. Maybe I'll make one for those too, or I will probably do that. My, let's continue. So, download, extract, put it into plugins folder. Okay. So 64 or 32 bits. So now I almost have to install it just to see. Then when that's complete, the plugin should be ready to use. Once we run a 32dbg, we can type ERC help in the command bar at the bottom to view ERC's help menu. To view the ERC's output, we must switch to log tab by clicking Alt L. So I can't see this image. Why couldn't they make it clickable? So error, the debugger must be attached to a process to use ERC. And it's apparently called ERC. So what does ERC stand for? Exploit development process help. So I can't see what ERC is. well, it's part of that, so we don't need to have that up. We can also set a working directory. ERC config. Yeah, let's do a short note on this. And I guess I will do the same name. So if I click this now, I think it will make one. And did it make it in the right place? No, probably not. Oh my, oh my. Yeah, so let's just... Yeah, it's in the right place. Woohoo! I was just blind. That's good. So, anything else would have been not very smart, right? So first, back. Let's actually cut this. And let's actually say S, because it is, right? And then we open this as a new tab, and we paste this. And we do install the latest release. I can't spell release today. Of x64 DBG. Get ERC and put it in the plugins. So in plugins. Well, 32-bit. And the same for 64-bit. I see, right? And then we have, this is what made me put it in the notes, because there's an interesting thing. So PowerShell such. No, I don't hate PowerShell. It's just prettier with SH. So set the working there. And it's kind of obvious that we wouldn't use HTTP student, right? Now all of your apps should be saved. Yeah, because they put the desktop. Debugging a program. However we want to debug a program, we can either run it through x32dbg or run it separately and then attach to its process. So it's the same as other programs. To open a program, we can select File Open or press F3. I wanted to attach the program, File Attach, or press Alt A. So open file is F3. Let's do it the other way around. And Alt A, attach to running process or whatever, you know. Oh, it will even give us a, a list. Right. We can just click something. Opens dialog. So we can select the process we want to debug and click attach to start debugging it. If we want to debug a process that's not shown in the attached window, we can try running as an admin. If you can't see the process, run. I guess I'll have to keep typing x64dbg as admin, right? So, good to remember. Getting help. If we wanted any help with either of these tools, we can refer to the documentation. Okay. And ERC documentation. Nice. We want these links. Put them over our notes here. X64 DVD. I'll get very quick at typing this, right? Docs and ERC docs placeholder. It's always a pretty thing to see. So right, we could actually close these two down. If you want any help, now that we have all our tools set up, we can start debugging our first software, try and find the Stack Overflow vulnerability and exploit it. Click here to spawn the system. I'm assuming we'll need something basic. Apply what you learn in this module when you try to, what's the name of its process. So we're going to just spawn this to attach to it. That's the only reason. And we get the name of it soon. Alright. We can just close these down. We don't need any notes or anything from these. I hope, like, right? Since I already deleted the other one, which was most interesting. Yeah, so let's clear this and let's do a X3. And I'm going to keep the scale and stuff because it's kind of good. So we'll get an IP soon. 129.43.22 and HTTP student and I guess Academy student. Very advanced passwords here. Right, I just realized. So we had it zoomed. We had it zoomed because of that bad one. This is a bit big, right? Yeah, let's scale the desktop. Let's keep it at 100%, right? Let's try this. So So I have it set so that when I make the window bigger, then it will actually... it should make text a bit bigger. Yeah, I think I might actually like the other one. X32 DBG. So let's check the preferences, and if we can easily set the font, which I hope. I can't even see this, it's too tiny. Maybe I should have left it at another percentage. That's what I'm thinking. So this is not the kind of settings I want. Theme. It's dark already, it's smart, it realized. Or it's set to that by the machine, of course. They should have done it manually. Oh, they can have. I think, why ever have a bright light default, right? I'm just checking for font size. So, what if I put the menu up over here? Yeah, that was the bottom. Yeah, let's make it easy. And actually, not 200, but 150%. I guess we could just maximize it like this too. So, what do you think of this? It kind of broke. This is Windows itself. Yeah, I think we'll need to see the full names of things. That's annoying. So what if I restart it now? Yeah, thought so. That's good. Modern, nice software, but it's too high also everything. And because of this, well, we'll see. Anyway, this is so much nicer than the other one. Immunity debugger machine. It was not nice. So we're just supposed to attach to free CD to MP3 converter. So let's see. Come on. So refresh and F5. I like it. So this is the name they want. CD extract. I can't even reach. I can't stretch my arms fully up, all the way out. So this one is answered. They just wanted us to make sure that we could connect, that kind of thing. Fuzzing parameters. First, stack bits buffer overflow exploration. We usually follow 5 main steps to identify and exploit the buffer overflow vulnerability. And this is what was in the cheat sheet here, right? So we put those in the notes. Yeah, so it's not just me that is hungry, my tummy also rumbled. We'll see if I can wait another half an hour. Fuzzing parameters, controlling EIP, identifying byte characters, finding a return instruction, jumping to shellcode. So, fuzzing parameters. Yeah, so we haven't had to do this really yet because we've been doing simple Linux programs where it's been either the single input that you get to straight when the application starts or a command line argument. So we haven't fussed anything for parameters. But we've been looking for EIP, we have been identifying byte characters, finding a return instruction, and jumping. Well, this is just, do you mean running it then after fixing all this? Or this is getting the information, this is just putting it together? Oh my god! Slav, jag kommer gubben. Yeah, my kid's knocking. Yes. I seriously, I can't really move. We'll see how it goes on training. I'm seriously. Let's see here. So, usually the first step in binary vulnerability exercise is fuzzing various parameters and any other input the program accepts to see whether our input can cause the application to crash. If any of our inputs successfully causes the program to crash, we review what caused the program to crash. If we see the program crashed because our input overrode the IP register, we likely have a stack-based buffer overflow vulnerability. All that is left is to exploit this vulnerability successfully, which can vary in difficulty depending on the OS program architecture and protections. Let's start by debugging a local program called, which we're already attached to, identifying input fields, or rather I didn't collect it because it just wanted to have the name of it there. As discussed in the previous session, we can either open our program with or run it separately and attach to it. It's always preferable to run it separately and attach to it to ensure we would debug it exactly as it is when run normally. This may not make a lot of difference for basic programs like this one, but other programs that rely on various libraries may face some differences, which is why we prefer attaching to a process. Once our debugger is attached to FreeCD to MP3 converter, we can start fuzzing various input fields. Depending on the program size, there may be various input fields to fuzz. Examples of potential input fields include text input fields, program license registration fields, various fields found in the program's preferences, open files, program arguments, remote resources, any file the program open, various arguments accepted by the program during runtime, any files or resources loaded by the program on runtime or on a starting condition. These are the main parameters we usually fuzz, but many other parameters may be exploitable as well. So let's take this as examples of GUI programs because it's fields, right? And in our here we have already user input, command line arguments, network commands, network environment variables. So GUI, what's the GUI stuff after this? Let's actually wait. GUI programs. So I'm thinking, should I make a new header here with command lines, or should I just make another one here? So these are level 4. So let's make this a 5. So it's just an addition. I don't really like this, that it's table. Let's edit it. So let's remove. There's a lot of space here. Oh? I don't know what I clicked by mistake. I was going to do shift control back forward. I don't know what I really did. That's a lot of space. So I'm not sure I like that those are bold, but let's see what it looks like. So this has a BR here actually. So it's not very lined up or anything. I might change it later. And actually the text too, you know. But let's read this. These are the main parameters we usually fuss. Could be other stuff. Let's actually. This means and other stuff, right? As any program may have many of these types of parameters, and each may have to be fussed with various kinds of inputs. We should attempt to select parameters with the highest possibilities of overflows and start fussing them. We should look for a field that expects short input, like a field that sets a date. As a date usually short, so that the developers may expect a short input only. Another common thing we should look for is fields that are expected to be processed somehow, like a license number registration field, as it will probably be run on a specific function to test whether it's a correct license number. License numbers also tend to have specific length, so that developers may be expecting a certain length only. And if you provide a long enough input, it may overflow. The same applies to open files, as open files tend to be processed after being opened, while developers may keep a very long buffer for open files. Certain files are expected to be shorter, like configuration files. And if you provide a long input, it may overflow the buffer. Certain file types tend to cause overflow vulnerabilities like WAV files or M3U files, due to the vulnerabilities in the libraries that process these types of files. Okay. With that in mind, let's start fussing some fields in our program. So I'm thinking, should I make a note that WAV and M3U files? M3U files are usually kind of short, right? But they could be long. Waves are usually long. So, fuzzing text fields. We go through the program's various menu items, and as we just mentioned, the license registration fields are always a good candidate for overflow, so let's start fuzzing them. I'm like almost, oh, I got an error. Right? Yeah, so I'm thinking this is time to get started to actually do stuff, and I have to leave in an hour. I have to leave in an hour, but I have to, help my kids with food, eat food myself, other stuff too. So I'm kind of thinking I'll check. Let's see who's online. Security Weekly. I don't think they're really like a stream that is on Twitch. They're like, they won't note the rate or anything. Let's see who's just online. Well, it sees that I'm online this time. I don't think there's a lot of people online. So we could always raid this dude, but he doesn't speak English, I think. So we could always raid this dude. So no one. So I don't know why I'm following a lot of people. I don't know who they are at all. So I don't know why. So this one is one person looking at Twitch. I think they're mostly YouTube. So this one is one person looking. I guess we'll just go there anyway. Right. So security weekly. I'm going back this way. Copy. Let's hop in here. So let's see. So I'm sorry we don't have anyone good to raid. Do you have any suggestions? I'm sorry we don't have anyone good to raid. Do you have any suggestions? I'm looking once more. I'm sorry we don't have anyone good to raid. Do you have any suggestions? Well, we'll continue this tomorrow. I hope. We'll see. Yeah, I think I will. A little time. So tomorrow I'm going to drive my mom to get her car to service. So I'm going to drive her from the service then, you know. So I'll start later.
Cybernair Dante says.
Yeah, thank you very much.
Have a good day. Thanks for streaming.
Right.
Have a good day.
Did I actually miss? I don't think I missed any message because I don't have this in my ear. For some reason, I don't have the other one here. Because I can hear stuff. So, yeah, so we'll continue this tomorrow, probably, but a bit later than it's not 8. Oh, right, I can hear. I didn't mute myself. So sorry. I didn't realize. Sorry for the echo. So sorry. Yeah, let's do the raid. So, raid, and pasting this dude, and we'll see. I don't think it's not interesting. It's just that I don't think they notice if you get a raid or if they have people chatting on Twitch. Maybe they notice chat. We'll see. And let's go to see on YouTube. So I wanna send the link to YouTube too. Two people on YouTube, and we have 10 people on Twitch. So thank you very much for being here, and we'll keep studying tomorrow. Let's see. I didn't click. So there the raid is going. So see you tomorrow, everybody. Though it's kind of early tomorrow, I guess, for some people maybe. So, if not tomorrow, the day after. So, I'm going to click the raid now. Let's see, and I'm going to get some food. Thank you, everybody.
Just person if the people around you can't trust to turn on the faucet and drink the water they're drinking without it being safe. So I think what you say is so important. So we're coming up towards the end of the interview, but I definitely want to give you a chance to share a little bit about how people can find out more about ICIT. What are some of the things you guys have upcoming?